So welcome to ORD Survey webinar number 14. I'm Jonathan Rawlings, project surveyor down here in Geometronics. So our standard topics discussed slide, we've had quite a few, and we're going to talk about some reality modeling tools today, point cloud tools within MicroStation. We are going to talk about reprojecting point clouds in ORD to start off. And I brought this up when we started these webinars. There's been some changes in the way you can attach point clouds in ORD and connect, and they've removed that ability to assign that source coordinate system. So we're not able to reproject if we're using a point cloud file that MicroStation does not read the header information that contains that coordinate system information. I've said it's been kind of convoluted in the past as far as doing that in MicroStation. And Rhonda did a webinar on Blue Marble and reprojecting in Blue Marble, which is still the preferred method, especially if you have more than 3 or 4 point clouds. But there is a method in MicroStation that you can do. So if you only have 3 or 4 point clouds, maybe 5 point clouds you want to do quickly, you can quickly do it in MicroStation. So I'm going to go over that today. And then we're also going to touch on clipping and exporting point clouds in that process. We will then look at what we referred to in V8i. In En-ROADS V8i had a tool called data acquisition. That same tool is available in ORD. No longer called data acquisition. It's called create terrain from point cloud. So we will look at that. And during that process, we'll also look at how to use sections to do that with the create terrain from point cloud. And if time allows, notice those have yellow bullets on them, we'll get into edit classification. And I do not think we'll get to ground extraction, tiling point clouds, or section key-ins, but I could be surprised. So reprojecting in ORD. So there's really just 4 main steps to make this happen. So we're going to have to set our project coordinate system in our MicroStation model. This is what we want to reproject to. We'll then attach our point cloud that does not have an assigned coordinate system on it. And then we're going to set that coordinate system of that point cloud in our point clouds dialog box. And then that will automatically force that point cloud to reproject on the fly, as they call it, within MicroStation. And then we're going to save or export that reprojected point cloud with the correct GeoCS. So I kind of ran through that super fast. It is a super fast process, but I'm going to jump into a demo right away and work through this process. And after we do that, we'll keep going with the other topics. So let me switch here. We're going to take a point cloud. Most likely this is going to be from our mobile scanner. And our latest statewide scan data is on the Oregon statewide Lambert system. And unfortunately, MicroStation will not read the header information where that coordinate system is contained in our LAS files. So it comes in as unnamed. So the first thing that we need to do is we need to know what our project coordinate system is or where we're wanting to go with this file. So I've went and downloaded some data over in Bandon on Highway 101 that was collected with the statewide scanning data collection this year. So I have 6 LAS files along Highway 101. These are all on the Oregon statewide Lambert projection. I've also got the aerial Lidar from Dogami that was collected in like 2014, I believe. That is also on the Oregon statewide Lambert projection, or 2992 for the EPSG code. So the first thing that I need to do, though, is assign the coordinate system for the model for my project. So to do that, I need to go to my coordinate system tools, and there's a couple ways to get to them. Notice I have the coordinate system set up in my quick access toolbar. I could also go up here to my search ribbon, type in chord. It pops up. I can left click on that to get it. Or I can drill into my workflows and tabs. I find that to be pretty cumbersome, so I don't usually do that. Again, that's why I put it up here. So I'm going to set this coordinate system. I know that Bandon is over on the coast. You know, I could go to the Geometronics Online Toolkit, go to the OCRS portion of it, figure out what coordinate system I need. And I need to set that here using the From Library button. So this is probably nothing new to anybody. And I know that this is on the OCRS Oregon Coast Zone. So I'm going to set that here. OCRS Oregon Coast International Feet. Notice all of our ODOT favorites are in international feet, and V8I, those were all set to meters due to a background setting that we had. Everything is now in international feet. So I can set my coordinate system that I want to project to or that my project is on. And now I want to attach those mobile scans that are on the Oregon statewide Lambert system. Let me first turn on my aerial imagery so you can see kind of what's going on. And then I'm going to attach these point clouds. So to attach the point clouds, you've got your reality modeling toolbox. There's a couple ways to get to these, as there is with everything. I can go to my reality modeling workflow. On my attach tab, I could do attach point cloud. I don't like to use this method because it skips some steps that I'm kind of used to. I can go to my home tab and go to my attach tools and drop that down and select the point clouds, which is the method I'm used to. And I've also taken this and put this dialog box or tool up on my quick access bar because I use it quite a bit. I can also open it that way. It's pretty handy. So to attach, I can go to my file attach, file drop down and attach, or use my, I call it the brain. It's supposed to look like a point cloud. Looks like a brain to me with a paper clip. So I'm going to attach that point cloud, those point clouds. Navigate to where I have those stored. And one of the things that's important in this process, because you're going to be making a couple different sets of pods, is to keep the different pods in folders based upon their coordinate system. Notice I have my aerial LiDAR in its own folder under 2992 and the mobile LiDAR in its own folder on 2992. So that's the Oregon Lambert files. So these are the ones that I want to attach. I have to go down and change my files of type. It automatically defaults to pod, which is the microstation point cloud file type. So I need to go down and change those to LAS. And I'm going to only do this first track, TO1 files 8, 9, and 10. I select those and go ahead and say open. And my thing popped up in the other screen. I'm going to bring that over. So this is the convert LAS dialog box. So since these were LASs, to be operational in MicroStation, they need to be converted to the pod format. So I've got several options. I can attach them or not. Again, to change these options, you just left click in them and drop it down, yes or no. I do want to attach them because I want to see where they're at. I can import my RGB or color values, intensities, classifications. Yes, I want to do all that. I don't want to really deal with the compression or spatial filtering right now. I always leave that to automatic. The spatial filtering you can use to reduce your point cloud. I don't really like the way MicroStation spatial filtering works, so I rarely use it. And then I've got this reproject option here. So right now it's currently set to no. If I set that to yes, it allows me to set, or it looks like it will allow me to set this source geo coordinate system. However, when I go click in this box, I can do the option to select. It looks like it allows me to select that, but then nothing happens. It gives me this dialog box down in the lower center of my MicroStation view, saying not possible to override the file GeoCS. You'll also notice that the name on that source GeoCS is set as unnamed. It could not read the format that our software uses whenever we create these LASs, the Leica software. It does, however, set the destination geocoordinate system to whatever is in the model. So I set my model to have the OCRS organ coast zone. So it automatically assigned that. So we can't really use this reproject option whenever we convert these LASs because we don't know where we're reprojecting from. So I have to set this to no. So I'm going to go ahead and convert these LASs to pods. Select OK. And it's asking me, where do you want to save these? So I'm going to save them in that same mobile 2992 file because that's what coordinate system these are on. So I'm going to go ahead and hit save. You'll see a progress bar pop up here. It takes a little bit of time. So it did one at a time. This is going to be number 9. And again, this is why you would not want to do, if you had 10 or 15 point clouds to work with, you wouldn't want to do it this way because you're doing one at a time with this method. So go use blue marble. And again, all my settings stay the same as they did the first time. I'm just clicking OK. It's going to save them in that same folder, and I just hit save. While that's still cranking, I think it just finished. Let me pull this up. So I just converted my LAS files from the mobile scanner that you downloaded from our project folder over to pods, placed them in the same mobile 2992 folder. So I have a number 8 LAS right here and a number 8 pod right here. Notice the pod file is about 1/3 of the size of the LAS, so significantly smaller to work with. And they are attached within my file. I can do a fit view, and you notice they are off in the ocean somewhere. So here's the Oregon coast, I'm assuming, and there's my files. And notice the geocoordinate system on these files is set to unnamed because it was not able to read that. If my geographic coordinate system in the model were set to that 2992, the Oregon statewide Lambert, these would show up in the right place. But because my model is set to the Oregon coast zone, they do not show up in the right place. So let me set the geocoordinate system, the actual geocoordinate system of these point clouds to what they actually are instead of this unnamed. And we can see what happens when I do that. So to do that, I can select them all. I can right click in this window, go to GeoCS and select from library. Again, I can drop down my ODOT favorites, and we have this in our ODOT's favorites, the statewide Oregon Lambert system EPSG 2992. I can go ahead and say OK on that. Notice the geo coordinate system is updating on those, and it has moved them on the fly, reprojected them on the fly, so to say. So I'm going to do another fit view, and it has now put them in the correct location based upon the geographic coordinate system of my model. So I've still got these point clouds here, but they have this 2992 coordinate system attached. I could work with them right now. If I wanted to map something from this, I could go ahead and do that. But every time I close and open this file, I would have to go set that geocoordinate system again because it's going to read it as unnamed. And I don't want to deal with that if I'm working on this for, a couple weeks or however long I'm working with it. So I'm going to export these pod files as in the correct coordinate system that I currently have them reprojected to. So I am going to select them all and do a file, and export. So here I can export these point clouds as a pod or an LAS if I wanted to. I could even do an XYZ, which we typically don't use much at all. But I could export this to an LAS if I wanted to use these in Topodot for some reason. Topodot needs to have an LAS for working with that. So this is an option to do that. If you had to reproject something real fast, a small little project you were doing, you could do it this way. I'm going to go ahead and do pods since we're working in MicroStation. I can export different classifications. So if I knew that this was classified, I could drop this down and select which ones I wanted to export. I'm going to do all of them. I don't even know if this is classified or not. I don't think it is. And I can reduce the density of this file. Not necessary if you're working with mobile data typically, but if you're working with static data or even aerial Lidar, which I'm going to do an example of that in a little bit, reducing the density of those files can really help with operations for downstream tools, such as the data acquisition or just reducing that density around a static scanner. For this, these are mobile. Again, I'm not going to do that. I'm going to change that back to 100%. So it's going to export all of the points. Again, I do want to include all of my color, intensity, and classifications. And my geocoding, so this is a very important box. I have different options here. It can take my GeoCS from the model, which is what I'm going to want, which is set to where I want it to be reprojected to. Or I can choose the input point cloud, which is going to export it back on that Oregon Lambert, or the name specified, which I can go in here and set it to whatever. I'm going to select from model because I know that's where I want it to go. I know that's set correctly. I can see in here, everything is looking like it's lining up. So I'm going to go ahead and say OK on this box to start converting these 2992 pods to a Oregon Coast Zone pods. And one of the things with doing it this method, I had all three selected at once. So it's going to merge them all together. So it's going to put files 8, 9, and 10 all in one big file. So I'm going to name this file as such so that I know what I did. I could do these individually, but I would have to select one, do the file export, select another, do the file export, and select another and do the file export. Again, you wouldn't want to do this method if you had 15 files, unless you wanted to sit there and do this 15 times. So I'm just going to merge them all into one so you can just see the process here. And I've changed that name TO1. Everything's the same here, files 8 through 10. And it is going to save it as a pod. Go ahead and hit save on that. Takes a few seconds. Notice my progress bars in the lower right of my MicroStation screen. There should have been 3 that popped up there. I think that was the third and final one. So it has now created my exported file. Let me show you that. And I messed up here. What I should have done, it created it 8 to 10 pod, but I put it in my mobile 2992 folder. I prefer to keep things arranged a little differently. So I would have created a new folder here called Mobile Oregon Coast, just to know that this is in a different coordinate system than these 2992 files. So I'm just going to cut and paste that into that new folder. You can do this in that dialog box. I skipped that step. This is the same outcome. So now I've got my new 8 to 10 8 to 10 pod. It's about the size of one of the LAS files, all 3 of those combined. So I'm going to now detach these files that are on that 2992 geocoordinate system. I have a detach button here. Again, I can also right click and do a detach. And then I'm going to attach that new pod that I just created with all 3 of those. Navigate to my folder that is on the Oregon Coast Zone and select that 8 to 10 pod. So now I've got one pod file. I've got all 3 of those files in this one pod file. It has the correct geo coordinate system, OCRS Oregon Coast, and it just pops right into the right place. So I could, if I ever wanted to, maybe I wanted to go to a different coordinate system, I could now export this one pod. Well, I could do a convert on that pod. Sorry, it is not export, it is convert on that one pod. And on this reproject setting, I can change that to yes. Notice it is now reading that source geocoordinate system as OCRS Oregon Coast, and I could take it to another one. I'm not going to do that, but just know that that's possible to do if you wanted to do it. So what about aerial LiDAR? A lot of times we get this from, either our LiDAR servers, our open topography, which is where I like to go first because it's so easy to download LAS files, and all of that stuff is on Oregon Lambert typically. So I have downloaded that from open topography. So I'm going to go ahead and detach this and attach the aerial LiDAR data here so you can see what happens with it. So in my point clouds folder, I've got an aerial LiDAR folder 2992. I can change my files of type. Again, it automatically defaults to pod. I've got LASs that I want to convert, so I can change that to LAS. I've got my aerial that I've downloaded from open topography. I'm going to go ahead and open it. Again, I've got my same settings. I'm going to leave all these as they were. And I've also got this reproject option that I had before. I'm going to leave it at no, but notice that my source geo coordinate system came in on NAD83 Oregon Lambert. So it does read the Dogami data correctly. So we've had discussions with Leica on this, and there's no solution to why the Pegasus does not export it correctly, or Pegasus Manager. So I'm going to go ahead and attach this, convert the LAS to a pod. I'm going to save it in my aerial LiDAR 2992 folder. And notice, since it read the coordinate system on the 2992 LAS, it automatically reprojected it on the fly, since my model coordinate system is set up to OCRS Oregon Coast, even though this is set up to Oregon Lambert. And it is in the right place. Let me show that. I think you can see it, but just in case you cannot, I'm going to set my presentation style to elevation. And my contours, so I can see the road through there. So here's 101 coming through here. There's a big sharp 90-degree curve with an intersection, and it's putting that right in place. Again, I could work with it this way, but I really want to have it on the Oregon Coast coordinate system because I don't want to have it reprojecting all the time. So again, I'm going to do a file export. I'm going to do a pod. Again, I can switch that to LAS. I'm going to do all my classes. This file is classified. So let me close that and show that real fast. Turn off my background image. So in your presentation styles dialog box, you've got your different presentation styles. I can look at RGB, which this isn't going to have. I can look at intensity. Elevation is most useful for aerial LiDAR in this instance. So I can go in here and turn off these different classifications. There's two classifications on this aerial LiDAR data that we pull from Dogami typically, unclassified and ground. So if I go turn on this unclassified or turn it off, notice all those buildings, trees, and other things have disappeared. I go turn off ground, everything goes off. So that's one way to tell if it's been classified. You go to look at the front view, turn on that classification, you see all those trees and everything come back in. So these files are classified. So I'm going to go ahead and export this to a pod in the correct coordinate system. Again, I'm going to take my GeoCS from my model, which is this Oregon coast zone. And this is where I can make that new folder, which I like to do. And name it appropriately. It's telling me it's finalizing the output file. And I would recommend you not click around in ORD while this is working. It very well may crash as you're doing that. So it has converted it. I'm going to go ahead and detach this to 992 pod and attach my Oregon coast aerial data. Go ahead and say open. Notice my GeoCS is now set to OCRS Oregon coast. And I am in place. I can confirm that with my background map just to make sure, or any other data that I may have that's in the right coordinate system. So there's my intersection in my aerial Lidar and the same intersection in my aerial image. Go ahead and turn that aerial image off. They can sometimes get in the way. So that's reprojecting on the fly, saving that point cloud with the correct GeoCS. Again, useful for, I'd say maybe 5 files, depends on how much you want to set there and click. If you have a bunch of files, I'd say more than 5 to 10, you may want to use Blue Marble to do this because it's going to be a lot easier on you. So the next thing that I wanted to talk about was the data acquisition tool. It is no longer called that. It is called Create Terrain from Point Cloud. And this tool I used quite a bit back when I was in the region. We would have our preliminary design group, our planners or hydro people come to us and say, hey, we need a DTM of this area just to kind of get some idea of what's going on to see what we can do. And oftentimes we would just have the aerial LiDAR and we would just create a quick DTM using the data acquisition tool from the ground points. Pretty quick and easy. Whenever we first rolled out ORD, I thought this tool was gone, but after some more exploration, it is in there and it's really quite functional, probably a little, in my opinion, maybe a little better than it was in V8i. So I have this area and I'm gonna clip out this point cloud because I don't want to do it on this entire aerial LiDAR set, which is pretty huge. So I've got an AOI. Let me draw an AOI. I don't actually have one in here, but let me go ahead and draw one in for the area that I want to create this terrain from this point cloud. So let's say the designer gave me a KMZ, I converted it to a shape, brought it into MicroStation. All that's possible, or I just drew it manually like I'm doing now. Maybe this is the area they wanted. So I just created a shape for my area of interest that I want to make this terrain. I'm going to drill in here and select that shape. And I want to clip this point cloud because I don't want to use this tool on the entire point cloud. So there are several ways to get to your clip tools. The first one, and probably easiest way that I think, is to use your reality model presentation dialog box. Again, if you do not have this open and docked and you're working with pod files and MicroStation, I would recommend you do that. It's used a lot. To get to that, go to your point clouds dialog, and this last button, the brain with the cube, is your reality model presentation dialog box. That will open this dialog. And one of the tabs in this dialog box is clips. So under these clips, I've got these other tools that I can do different types of clips and different things to them. I can also get to it under my reality modeling workflow, and I believe it is attach. Yes, the attach tab and then clip is the same thing as working in this tab right here. So I just selected that button up here, so it brought up my tool, clip point cloud. I'm going to go ahead and show you up here. I can do this create clip on this leftmost button within this tab. Same thing. I have different ways I can do it. I can do it from a block, oriented block, all different kinds of things, shape and element. So in this particular case, I have an element for that AOI. It is currently selected. Notice I have one thing selected. It is that AOI. So I'm going to choose this element command. I can name this clip. I'm going to go ahead and call it AOI. And I've got two different modes. I have boundary and mask. So boundary will clip everything outside of your element, and mask will keep everything outside of your element. So I'll show you how those can work. And then apply to all. If you had multiple point clouds and you didn't want to select a point cloud, you could do apply to all, and that will just apply it to all the point clouds you have selected. In this case, I only have one, so it's not really going to matter. So I have my set to element highlighted. In my lower left, it's asking me to accept or reject my selection. I just left click in my view window over here and let it think for a second. And it clips out all of that extra point cloud data that I do not want. Notice under my reality model presentation dialog box, I now have under my clips tab and the clips dropdown, a clip that's called AOI here. I can do lots of things with this. I can rename it if I wanted, maybe. Not totally necessary. It's telling me what pod was used for this clip. If I had multiple pods that were used, it would show them all. I can turn it on and off using the check box. Notice this changed from active to inactive. That's just another way to turn things on and off with the clips. I'm going to leave it on. And I can also change the mode. So right now it's currently set to boundaries. So everything outside of that element is clipped. I can switch this to mask and it's going to swap it. That is not useful in this situation, but there are situations where it is useful if you're using these clips in cross sections and different things. I actually use this boundary and mask quite a bit working with pods. So I'm going to leave it to boundary. And I want to export only this area because I'm going to use that data acquisition or create terrain from point cloud file or tool. So in my point clouds dialog, so I want to export this clipped area as its own point cloud. I can select this point cloud in my point clouds dialog box, go to my file menu, do an export. And it's asking me in the lower left, again, you may set here for a while. Since I had it selected, I don't have to accept or reject it. But sometimes if you don't have it selected and you do a file export and you just kind of set there, nothing's going to happen. It's going to ask you to accept or reject that. So I'm going to export it as a pod. Again, I could export it as an LAS as well, but I'm going to do a pod. And my region filter, this is important. It says all. So if I leave this set at all, it's just going to export that same file that I had that is not clipped. So I want to set this to clip, and that's only going to export the area within that clip area. Classification filter, I could export just my ground class if I wanted, which is all I want to run that data acquisition tool on. I'm going to go ahead and export all, and to show you why when I get to that tool. Density, this is where I could reduce the density. I'm going to go ahead and do that since I'm running this data acquisition tool on it. I know I don't need all of these points to run that tool on it. So I'm just going to say I want 60% of the points there. And I'm going to keep all this stuff. And it's in the right coordinate system. So you could go ahead and just say, take the GeoCS from the model. Say OK on that. And I'm going to name this file something that relates to what I've done here. So I know I've clipped it. So I'm going to put clip, and I know I did. Actually, I'm going to put AOI clip And I know I reduced it to 60% of whatever it was before. So I'm going to go ahead and hit save on that. It's going to think, and I'm not going to touch any buttons while it thinks. So it is done thinking, and it has exported that file. I'm going to detach this entire file. Notice if I turn off this clip, I've still got my entire file here. And I don't really need that clip anymore. So I can go ahead and delete it. I can just right click on the clip name, delete clip. And hopefully it doesn't crash when I do that. And I'm going to detach this whole point cloud and then attach that clip. And one of the reasons I like to clip these out is the size. If you notice the size of that full aerial pod, 342 megabytes, my clipped version, 25 megabytes. So it will perform a lot better in ORD with it reduced. So I've now got my clipped pod in my file, and that pod does still contain all of the classifications. So I'm going to go look at my presentation styles. I'm going to turn off my unclassified. Notice all my buildings and trees disappeared. So everything is still there that I may or may not need. So let's talk about the create terrain from point cloud tool. And I can tell I'm not going to get to those extra tools that I had talked about, but hopefully we can get through this. So again, this is the replacement for the data acquisition tool in En-ROADS V8i SS2. To get to this tool, I need to go find my terrain tab, which for us is most likely going to be in the survey workflow. Under your terrain tab, so I'm in my survey workflow, terrain tab. Under this additional methods, I have create from point cloud. So this is going to create a terrain from my point cloud. It has nothing to do with my ORD survey fieldbook. It goes directly from the point cloud to the terrain, much like the data acquisition went straight from a point cloud to a DTM. So, and this tool does work off of whatever is the active settings on the point cloud, settings being classification. So if I don't want to run this tool on all these trees, it's just going to make my terrain pretty ugly, and the designers don't really want that. So I'm going to turn off that unclassified and run it only on the ground class. And why that didn't go off, I'm not sure. Let me try this again. There we go. I think it was a display thing. So now all my buildings and trees are turned off. Let me go back to my tool, create from point cloud. So on my left here, I have, this is the actual terrain name that it's going to create. You can rename this. You can double click in there and rename it, or use this rename terrain model button. I'm going to rename it because we have different, oftentimes you run this a few times, so you get kind of a setting that you like, or you get a good terrain that you like. You've got two different filters, the tile and the 10 filter. So I'm going to run a couple different versions of that. So we're going to start with the 10 filter. So I'm just going to call this 10. And one of the settings that's can change things a lot is this Z tolerance. So I'm going to go ahead and define what Z tolerance I use. So I'm just going to go ahead with that 0.25 on this, just so that we name it first. And you can change the name of these terrains once you create them as well. So I've got a box up here for terrain models. If I had another terrain model in my file, in my DGN file, I could append whatever I'm doing to that. I could add it to it. I don't have anything yet, so none of this is active. My projection, I can't change this. It's already in OCRS Oregon Coast. That's what my model is in, so it doesn't let me change any of that. So my filters, we've got two different filters. We have the tile filter and the 10 filter. Or you could say none. So you could just run it straight on the point cloud. It's going to bog your computer down. You're not going to be able to use it. So I would not do that. You should always run the filter, a tile or 10 filter on these. So the way I understand these tile and 10 filters. So the tile filter, you actually assign the tile size that you want it to go to, and it divides the point cloud based on that tile size. And then it either keeps or removes the points within the plane of the tile using what Z tolerance value you have set here. And the Bentley recommends that you set your tile length to be 3 times the distance between your points in your point cloud. You can tweak with these. Like I said, you're going to do this probably in iterations, trying to find something that's not too big, but not too small, that shows, you know, the definition that you want to see. So you have to kind of tweak with these a little bit, and you'll do it a few times. So the 10 filter right here, the way I understand this is it divides the point cloud into tiles of 2 million. So it starts out with 2 million points in one tile, and then it just triangulates that, and it just keeps tiling it and keeps making triangles with that until it gets to a certain point. There's the Z tolerance that you set for the points that it keeps or throws out based upon that triangle plane. So it just keeps doing that repetitively. The 10 filter takes a little longer than the tile filter. And in my opinion, the 10 filter makes an uglier contours. So anyways, we'll maybe see that as we keep going here. I'm going to have to get going to get through this. So let me just do a couple of examples here. I said I was going to do the 10 first with a Z tolerance of 1/4. I'm going to go ahead and leave it at coarse. You have coarse and fine. Coarse will take out more points than fine. Fine will leave in many more points. You'll get a lot more points around break lines, but you know, depending on what you want, you can choose that. One of the things you can do is run this test filter here. This shows you the number of points before the filter and the number of points after the filter. So in this case, with these settings, I had 325,000 points in this clipped pod, and it is filtering out 87% of those and leaving me with 40,000 points, which is quite a few points for a terrain in this area. I'm going to go ahead and say okay on that just to see what it looks like. I can set my feature definition. I've got it set to existing contours and triangles. And this triangulation options is really just for your edge triangles. I like to set it to max triangle length just so I don't get all those long slivers along the side. You can bump this up. And then I do include my spot features so that I can see all the points that it makes. So I'm going to go ahead and say import, and that is going to create a terrain from this point cloud using that filter. Notice it did it pretty fast, I think. So one of the things I've also noticed is this tool, if you do not delete this file right here from this box, this tool will keep popping up. I think it's an error. So I'm going to go ahead and delete that, remove that terrain model from this box and close that. And hopefully it doesn't keep popping up on me. So I have created a terrain. It is under my Open Roads Model tab. Drop down my Webinar 14 demo, go into my terrain models under my feature definition. I now have a terrain that is named the 10 under our 0.25, which is what I told it to name it. And it has, let me turn off my point clouds. So it created a terrain for this entire point cloud in a pretty quick time. If I go to front view, notice I've got a couple areas maybe that weren't correct, but it's overall a pretty nice model. So let me go create another terrain using the tile filter. I'm going to turn my point clouds back on. Again, I'm just looking at the ground class. I'm in my terrain tab of my survey workflow, additional methods, create from point cloud. Here, I'm going to rename this. I'm going to call it tile, and I'm going to go with 1 foot. Z tolerance 1 foot. Minimum tile points and max tile divisions. Bentley recommends using 5 and 5 for both of those. I haven't seen much of a difference in changing that or any benefit to it. And start tile length, I'm going to go ahead and leave here at 10 feet and run this test filter. So notice I went from 325. Now I'm getting 68,000 points. So I'm getting slightly more points with this. I can adjust this. Let's say I want to start my tile length at 15. Now I'm reducing it 90%. So I'm only getting 35,000 points. I'm probably going to go back to 10. And I'm going to go ahead and import this tile 1 foot. Notice it created another terrain here. But before I close this box, I want to be sure that I remove this terrain model from this box because it will drive you crazy. So now I've got 2 terrain models in here. And the problem I have now is that they're both on the same level. So tile 1 is on E-Terrain Display General. 1025 is on E-Terrain Display General. So to make it so that I can see both of them, or either one of them, to turn them on or off, I need to go switch that level. So in my properties dialog box with that terrain selected, I can go just change the level of that terrain. And I'm going to set that to that one. It's kind of at the front. You see how I say this box pops up? I don't know why it does that. Hopefully it doesn't keep doing that. Okay. So I've now changed this 1025 to a different level, so I can go turn it off so that I can see this last, and it's still doing it. Okay. So that I can see this last terrain I created, this tile 1. So here is the model created with the tile filter. And, we could do a comparison and see those, but, you can make a judgment on what you prefer. I prefer the tile. Some people may prefer the 10. I think it makes it a little cleaner with the tile. You will get more consistent results as far as point spacing and different things. So has anyone used this in ORD yet?
Yeah, John, I haven't used it with a pod, but I've used it with LAS. If you just go terrain from file instead of through the additional methods, it worked with LAS.
Yep. So let me show you real quick. We got a couple minutes. Maybe I want to put an exterior boundary on this. I'm going to do it on my tile 1, which I believe is the one that's displayed. Yes. So I can put an exterior boundary on this. I can also put interior boundaries. We're going to do both. So I'm going to select that AOI that I've got because I want to use it as my exterior boundary. I think it's kind of ugly how, it leaves some gaps around the edges. So to add that boundary to the terrain, I can go up here to my feature management dropdown, add features. Since I already have it selected, it's just asking me to locate my terrain model to add my elements. I can left click on anything there, and then data point to add that one selected element that I selected prior to initiating the tool. And what kind of feature type do you want to make this? I want to make it a drape boundary. All of that AOI is at 0. So if I make it just a boundary, it's going to triangulate down to 0. So the drape boundary will keep the elevations along there, which is what I want. So I can left click to accept that. And it adds that boundary to the terrain. Notice this area I pointed out down below has now triangulated and filled out, and it has not triangulated down to the boundary. So if I want to do an interior boundary, maybe I want to outline this building right here. I can do a section across that. Typically, we're doing vertical sections. I want to do a horizontal section across this point cloud. So in my presentation dialog box, I've got a sections tab. I can create a quick section here. And I've got different options to do here. I'm just going to use this first one, and I'm going to make sure it's a horizontal. Typically, we're doing vertical, generally, but I'm going to go ahead and do a horizontal here. I can modify all these settings later after I get my cross section in there. So let me draw this cross section in here. And I can show you how. Let me turn off that terrain. Show you how you can easily go put an interior boundary around this building. So here I've got my cross section. I'm going to go ahead and turn on the remaining classifications. So I've got my roof of my building there. Go back to my sections tab. Left click on my section name. I'm going to set my thickness to like, let's try 15 feet so that I can actually see the difference in the ground and the building. And I'm going to go forward and back 3 feet. And I'm just going to move this point cloud. I think I'm going the wrong way. So let me go up with that till I get to the building. So I'm starting to see, this is the building right here. And I'm starting to see that roof line come into my cross section. Looks like we're there. Go back one more. Yeah. So I can just take a line, snap to that point cloud, draw an outline of this building. This is a manual way. I'm sure there is a tool in TerraSolid that will magically export all these buildings. I don't know what that tool is, though. But this is relatively quick and painless as long as you don't have a lot of these to do. So I just created a shape of that building. Let me tile these again. I can then go select that shape, do another feature management, add features, locate my terrain model, select any element of the terrain model, data point to add that one element. And what kind of feature type do you want? Again, I'm going to do a drape void because I don't want it to triangulate to that. I want it to keep the triangles as is, but get rid of them within that. So I have just removed the triangles within that building. Turn my point clouds off. And I've just done that with an interior boundary. So that's data acquisition in ORD. There's a few more things to mention about it, but it's going to take me too long. So we'll have to save that for a different one. Well, that's the webinar for today. So I've got more topics, of course, always. So thank you all.